Hello, my dear students. Are you ready for topic 2 of chemical bonding and molecular structure? Yes. So let's get into the chapter right away. Yes. So in the previous class, I have discussed about the chemical bond formation, octet rule, valence electrons, causal Lewis approach, and modes of chemical combination and ionic bond. And also till the formal charge of atoms, is it not? So let's have a quick revision of what we have studied in the previous class. So modes of chemical combination. The chemical combination or chemical bond formation can happen by transfer of electrons, okay, or by sharing up of the electrons. So when there is transfer of electrons, you get the ionic bond or electrovalent bond. And when you have sharing up of electrons, when there is mutual sharing of electrons, yes, you have the covalent bond. Okay. And what about the coordinate bond? Coordinate bond is a new type of bond where the electrons needed for the bond formation are donated by one particular atom. You got it? The electrons needed for the bond formation are donated. Both the electrons or all the electrons needed for formation of bond formation is donated by one such atom, and that is called as coordinate bond. Okay. Now, so how to denote it? It is denoted by using a arrow mark like this. For example, if you have an atom X and it is bonded to atom Y. Got it? So for a bond, making a bond between this X and Y, we need two electrons. But Y is not contributing any of the electron, and X is contributing the two electrons needed for the bond formation, and that is called as coordinate bond or dative bond, usually denoted by this symbol. Okay, so ionic or electrovalent bond, you know now, it is sodium and chloride is the best example, where sodium, you see the octet, it is 2, 8 and 1. So if it loses one electron, it achieves a stable octet, and chlorine has 7 electrons in the valence shell. So if this one electron is gained, it becomes 2, 8, 8. So to achieve this octet configuration, both your sodium and chlorine are tending to lose one electron and gain one electron and form a electrovalent bond or a ionic bond. Similarly, with magnesium and oxygen also, one such bond can be formed. And here you see in magnesium we have 2 electrons in the valence shell, and let me zoom in so such that you can have So now it is clear. Yeah. So magnesium is losing 2 electrons, so it is gaining a 2 positive charge, and oxygen is gaining a 2 negative charge. So factors affecting the formation of ionic bond, we have to worry about the ionization enthalpy. Ionization enthalpy means what? The energy released during the ionization of an atom. Okay. So when alkali metals, they tend to lose one electron, that process is called as ionization, and the energy, okay, see, the energy required to remove an electron, this is the energy required to remove an electron from the outermost shell. So for the sodium atom, you have to supply an energy of 496 kilojoule per mole to remove one electron and make it as Na plus. Similarly, in the case of magnesium, you have to remove 2 electrons. So 743 kilojoule per mole energy is to be given, and that is called as ionization enthalpy. So lesser the ionization enthalpy, more easily the bond formation can be formed. Okay. Now coming to the electron gain enthalpy. Now when you take the chloride, when you take the chlorine atom, it has to take up one electron, is it not? The electron given by sodium, that energy is called as the energy released during that electron gain is called as electron gain enthalpy, and during the electron gain energy is released. That is why it is given in the negative value. So more negative value means more easily, because more energy is given out means the value is more negative. So if it is more negative, more energy is given out and the atom is more stable now. So if the atom releases more energy during the electron gain, it is a stable one and readily it forms the anion. Okay, after forming the cation and anion, what has to be done? This cation and anion has to go and sit in some place to form the crystal. Okay, they have to arrange themselves in certain points or certain places. That is called as the lattice point, and they form a lattice cell like this. Okay, so they form a lattice cell like this, like a cube. So this I have to erase. Okay, don't worry this part, that is mistakenly drawn. So imagine each sodium cation go and sit in the corners of this cube. This is called as a lattice, and chlorine sits in the middle of the lattice cell. So to make such arrangement, okay, they have to go and sit in such a cell. When they do form a lattice like this, energy is released, and that energy is called as lattice energy or lattice enthalpy. This is also very important for the formation of an ionic bond. So why they have to form a lattice like this? Because of this only they have a perfect shape, since they are sitting in their own place, a perfect place they are taking. That is why they can form a crystal. Crystal means what? A perfect shaped molecule. A perfect shaped compound is called as a crystal. That's why they form a crystal. And lattice energy depends on the size of the ions and the charge of the ions. This is very important. So how the size of the ion should be? Smaller the size, greater will be the lattice energy. And charge on the ions, it must be greater, so that the ionic strength attraction is also greater. So these 2 points are very important with respect to the lattice energy. So this is a very important question. Factors affecting the formation of ionic bond and a subsection lattice energy. Okay, some general characteristics of ionic compounds are given. I told you they always exist as crystalline solids. And what about the melting and the boiling points? It is high because they are perfect crystal and they have high interionic force, so we have to supply more energy to break the bond. That's why they have high melting and the boiling points. And they are ionic in nature. That means they are polar. They can form positive charge and negative charge. They have poles, positive pole and negative pole. That's why they are polar, and they are soluble in polar solvents. And electrical conductivity, when they are in the solid state, they are not having any ions. Only when they are in the liquid state, they form ions, is it not? As far as they are in the solid state, they are not conducting, but once if they go into the molten state or when they are dissolved in water, they are having a very good electrical conductivity. Next, coming to the covalent bond. So how covalent bond is formed? By mutual sharing of electrons. Now you see, if you have 2 hydrogen atoms, what is the formula for a hydrogen molecule? It is H2, and you need 2 hydrogen atoms for this. So each hydrogen with 1 electron, and they are formed. Okay, a bond is formed between them. Now count the number of electrons. Okay, count the number of electrons surrounding each hydrogen atom. It is 2. So though it is not 8, this is acceptable. This is an exceptional case where some atoms do have less than 8 electron and still they are stable, and that is called as an exception, and hydrogen is one such exception. And coming to the oxygen molecule, oxygen has, the formula for oxygen molecule is O2. For that you need 2 oxygens, and each oxygen has 6 electrons surrounding it. Now you try to make a single bond between them. Why not a single bond exists between 2 oxygen? Okay, that's the question. So So imagine, yeah, so I have this, and so one single bond I am making. Now you count the electrons surrounding each oxygen: 1, 2, 3, 4, 5, 6 and 7 only. And surrounding this oxygen, 1, 2, 3, 4, 5, 6 and 7. So they have only 7 electrons when you make one single bond. But if you share two electrons and make a double bond, you count the electrons surrounding each oxygen: 2, 4, 6 and 8. 2, 4, 6 and 8. So each oxygen now has 8 electrons. That is why they are stable and they form the double bond between them. Similarly, you can try for other molecules like water, ammonia and so on. So in the case of ammonia molecule, see, nitrogen has 5 valence electrons. So 1, 2, 3, 4 and 5. So with 3 hydrogen atoms, it is forming a single, you have 3 hydrogen atoms in the ammonia molecule. So yeah, okay. So this is for hydrogen, it is making 3 bonds and 2 electrons are remaining unused, and this is called as the lone pair of electrons. Now you count the number of electrons surrounding the hydrogen. Yes, it is 2. For this hydrogen also it is 2. For this hydrogen also it is 2. Yeah, for hydrogen it is okay. If it has 2 electrons surrounding it, it is the stable one. Now for nitrogen you count 2, 4, 6 and 8. That's why it's a stable molecule, and this is the structure of the ammonia molecule. So first you must know the valence number of electrons surrounding each atom, and then you have to try to make single bond and double bond. So try to make double bond also with one hydrogen. So you cannot have, hydrogen has only 1 electron, so you cannot make a double bond, is it not? So that's a problem there. So this is how you have to draw the Lewis structure, and that is a very important question for your exam. So for other atoms, carbon dioxide, oxygen, ozone, O3 is ozone. So they have given the Lewis dots as well as the type of bonds between them. So in each of this, if you can count the number of electrons, you will get to know that they have 8 electrons surrounding them. So shall we try for this SO3? Okay, let's take this sulfur. Sulfur has 6 electrons surrounding it. Okay, so like this. Valence number of electron for sulfur is 6. So if it makes a double bond with oxygen, I have 3 oxygen, right? So if it makes I'll draw here. So if it tries to make a double bond with 3 oxygen, okay, now you count the number of electrons surrounding the oxygen, this and this. So 2, 4, apart from this I have 2 more, right? 2, 4, 5, 6, 7, 8. Because oxygen always has 6. So sulfur had 6, right? If I can change the color, you can easily understand. I'm sorry, I've closed it. One more time I have to go. So we were doing something over here. Yeah, we were doing something here, right? And I'll take the pencil. Yeah, eraser is here. So you have the sulfur. 1, 2, 3, 4. Yeah, this is the sulfur's thing. And now I have 3 oxygen. Yeah, okay. Now for oxygen, 1, 2, 3, 4, 5, 6. Okay. Yeah. So try to make double bonds. If I make double bond, oxygen has 8 electrons. But what about the sulfur? That's the problem. Okay, here. So I make double bonds like this. Oxygen has 8 electrons. But you see the sulfur? Sulfur has 2, 4, 6, 8, 10 and 12 electrons. So that is not correct. Is it not? In this case it is not correct. Okay, so sulfur cannot have 3 triple bonds. So when you make only one double bond, and if you make 2 single bonds, then you will get the octet structure. Now you count it: 1, 2, 3, 4, 5, 6, 7, 8 for this oxygen, 1, 2, 3, 4, 5, 6, 7, 8 for this particular oxygen, and 1, 2, 3, 4, 5, 6, 7, 8 for this particular oxygen. So this one. Now for sulfur you count 2, 4, okay, 2, 4, 6, 8. So I have to make one double bond, one single bond, 2 single bonds. If I make 2, 4, 6, 8. So 8 electron for sulfur is achieved, and that is why I am doing it. So similarly you have to try for other atoms also. And these are some atoms which have charges in between them. So that is also given here, right? So how to find out this charge? For this only we need the formal charge calculation. Okay, so in the formal charge calculation, let's take the example ozone. So 1, 2 and 3. So number of valence electron is 6 for the oxygen atom 1. Minus 2 means the lone pair of electrons, minus half into 6. 6 is number of bonds surrounding it. So 3 bonds you have. So totally 6 electrons. So 1 by 2 into 3. So the charge is 1 plus 1 for this. And for the second oxygen it is 0. And for the third oxygen it is minus 1. This I have explained you in the previous video so that you can refer to. And for today we have to discuss some limitations. As I told you, in hydrogen you cannot expect 8 electrons. It can have only 2 electrons. Though it is having less than 8 electron, but still it is a stable, it can still form a stable compound, and that is why this is a exceptional case in your octet rule. Next, odd electron molecules. See, sometimes you have charges on them. Sometimes they form coordinate bond. So there 1 electron is 2 electrons are given by one atom, so they have charges on them, and there is odd electron on the nitrogen. So this is also a stable one, but they are not having but they are not following the octet rule, but still they are stable. So this is another exception. Next is expanded octet. Now when you take this PF5, phosphorus pentafluoride, it makes single bond. Okay, with each fluorine atom it makes a single bond. So yes, fluorine gains octet structure, but when you count the number of electrons surrounding the phosphorus, it is 10. Though it is more than 8, it is still a stable one. Hence this is the example for expanded octet. Okay, PF5 and SF6. So this is one example. Now what are the drawbacks of this octet theory? As per the octet theory, noble gases do not react, is it not? Because they have only if there is a deviation in their octet structure, they do tend to lose electron or gain electron, and they can become an octet structure and form a chemical bond, and that is the driving force, main driving force for chemical bond formation. To achieve a stable octet is the driving force for the chemical bond formation. So, but your inert gases are not supposed to form such compounds because they already have a stable octet structure. So there is no need for them to gain or lose electrons and make a chemical bond formation. But still, there do exist some inert gases like xenon which can form chemical compounds, like xenon fluoride, xenon difluoride, xenon tetrafluoride, xenon oxyfluoride, and so on. So this is not explained by your octet theory. That is a drawback. Got it? And also from the octet theory we cannot determine the shape of the molecule. That is one more problem. Yeah. Okay. So why this? What we understood, We understood what is a Lewis structure and what is ionic bond, what is covalent bond, and what is coordinate bond. Next topic is, now you know what are the types of bonds. Now we have to understand some bond parameters, some characteristics of the bonds, some properties of the bond we have to see. And what are they? They are bond length, bond angle, bond enthalpy, and so on. I'll explain you one by one. So what is bond length? Imagine these two are the atoms and they are forming a bond between them. And how you're finding the length, and if they are forming a bond, you have to count from the center part. Imagine this is the central part of the each atom, and if you draw a line, you will get the radius of each atom. And if RA is the radius of atom A and RB is the radius of atom B, and the total or sum of RA and RB is the bond length. Got it? What is bond angle? For example, if you take the hydrogen atom, the bond angle, it forms only one single bond and the bond angle is 180 degree. But when you take water, it is not 180 degree. It actually has a bond angle. It is slightly, it is having a V shaped or a bent shape. Okay, when it has a bent shape, this bond angle is not 180, but it is some other. Okay, it has some other bond angle. This is called as the bond angle. And what is bond enthalpy? Enthalpy means heat or energy. I have already told you. So what is bond enthalpy? The energy required for breaking any bond. Okay, the energy required for breaking any bond is called as the bond enthalpy. So when there is a single bond, you can supply some 200 kilojoules of energy. And when there is a double bond, you have to supply 400 kilojoules of energy. So more the bond, more the energy you need to break. Is it not? So you can compare this table. When there is a single bonded bromine atom, it is 196 kilojoules of energy you have to supply to break the bond. But if it is C triple bond C, you have to supply an energy of 836 kilojoule per mole. So more the number of bonds, more stronger the bond, and hence you need more energy to break them. Got it? Next, coming to the bond order. Bond order is nothing but the number of bonds between any two atoms. So if you have a single bond, the bond order is 1. If you have a double bond, the bond order is 2. And if you have a triple bond, actually nitrogen has triple bond between them, so the bond order is 3. Okay. Next, coming to the resonance structure. What is a resonance structure? Resonance structures are nothing but they have the different ways of arranging atoms. Okay. So for example, in ozone, how I have so here the double bond is between this oxygen and this oxygen. What is the another way of representing this? The double bond between first two oxygen atom and a single bond here. Is it not? But still both are same. Okay, so that I am denoting it with like this. So if I draw a structure like this, so like this, and dotted lines all over here. What does it mean? So the double bond can exist here or here, but both are same. And this is called as the resonance hybrid. It's a hybrid. It's a combination of both the structures. These are resonance structure and this is the resonance hybrid. This is similar. Okay, both these are similar to this particular structure, and this is called as resonance hybrid, and this is resonance structure. So what is resonance? Different ways of representing a molecule. So for example, I have given you more examples. So let's take this carbon dioxide. Carbon dioxide, it has a double bond here and here, is it not? It has double bond in between this carbon and oxygen and this carbon and oxygen. And in the under resonance structure, it has a triple bond and single bond with charges. So see, that triple bond also is shifted here and it has charges. So this is called as resonance structures. And if you can represent all this in one particular structure, that is your resonance hybrid. The next topic is polarity of bonds. Polar and non-polar covalent bonds. Now, when do we have this polarity? Whenever you have the charges, whenever you have building up of the charges, then they have poles, a positive pole and a negative pole. That is called as a polar compound, right? So when you have poles, when you have charges, they are polar compounds. When there is no charges, that is developed, then it is called as non-polar covalent bonds. For example, hydrogen and chlorine, if you take, there is no difference in their positive and negativity. Okay, there is no difference in their positive and negativity. That's why they are non-polar covalent bonds. But if one atom is, okay, but if you take hydrogen and chlorine, so chlorine is electronegative in nature and hydrogen is electropositive in nature. There is a difference in their electronegativities and hence they develop charges. So when I write this del negative and del positive, this is called as del. Okay, delta, this is a symbol. Okay, delta symbol. When I write this delta positive, it is a partial positive charge. When I write delta negative, it is the partial negative charge. So when chlorine was alone, it has a negative charge, a full negative charge. But after forming the bond, hydrogen, okay, after forming a bond with hydrogen, it is now having not the full charge but a small charge, that's a partial charge. That's why I am writing a partial negative charge. So these type of compounds are called as polar compounds. When do we expect the polar compounds? Usually with the electronegative atoms like halogens. Electronegativity means what? The ability of an atom to gain an electron, to take up one electron. They are electronegative. All your fluorine, chlorine, bromine and iodine are electronegative in nature, and if they try to form for compounds with another other atoms, then there is a building up of partial negative and positive charge and they form polar compounds. Then you can have the polarity. Okay. Finally, dipole moment. So what is dipole moment? So due to the polarity, the polar molecules are also known as dipole molecules because they have two poles, right? So they are polar molecules and they have dipole molecules and they possess a dipole moment. So what is dipole moment? You can measure the amount of the charges, how far it is polar. Okay, the separation or the measurement of how far the atoms are polar is called as the dipole moment. So how can we calculate that? We can calculate it by charge into the distance of separation. And what is the unit of this dipole moment? It is d by units. And 1 dBi has the unit of 3.33 into 564 into 10 power minus 30 centimeter. Okay, and so dipole moment is a vector quantity. It has directional property. Why I have drawn a directional towards fluorine? Because fluorine is actually attracting the electrons towards itself. Though hydrogen is not electropositive or electronegative, it tries to form a covalent bond between them. Though it is a covalent bond, mutual sharing of electron between hydrogen and fluorine, because of the electronegativity of fluorine atom, the electrons are pulled. Okay, electrons are pulled towards the fluorine atom. That is why it is gaining a partial negative charge and this is gaining a partial positive charge. So this is a vector quantity. So there arises poles and there arises dipole moment and there is a vector quantity because towards fluorine and not towards hydrogen. Got it? Okay. So where do you find the application of this dipole moment? When you have to determine the polarity of the molecules, when you have to determine the shape of the molecule, and when you have to determine for the molecules with zero dipole moment, it will be linear or symmetrical. Is it not? Here, see, though in this case, so this bond is actually pulled towards fluorine. They are not symmetrical in nature because of the dipole moment. But if they have the dipole moment, they are symmetrical. They are not sharing. They are not equally sharing, is it not? So that's why they are not symmetrical in nature, and those molecules have unsymmetrical shapes and will be either bent or angular. So in the next topic or in the next session, we will be discussing the valence shell electron pair repulsion theory, a very important theory, and also it helps us to understand, predict the shape of any molecule. Okay, this will help us to understand the shape. As I told you, here, sometimes it is unsymmetrical or bent or angular. Not always they are linear and symmetrical. Sometimes they are bent and angular or unsymmetrical. So how they are formed and how can we determine them? That information is given by your VS EPR theory, and that we would be discussing in our next session. Okay, so until then, I want you all to draw the shape of all the molecules given here. You have to try to make double bonds between them. So you have to take this carbon dioxide as an example and write down the valence number of electrons surrounding the carbon, and try to make single bond and count the number of electrons. Try to make double bond and count the number of electrons. So the structure with 8 electrons surrounding each atom is going to be stable one, and that is the accepted one. So if you know this theory properly, you're not going to make any mistake in drawing the formulas. Okay, so till then, keep studying, don't lose your heart, and we would be meeting soon in regular classes, and we would be studying more, okay, in detail about all this. So until then, bye.